2 months ago, I created one simple AI-generated music video for my gym sessions, just one video. Then I thought, what if I could upload it automatically to YouTube? So I built a small MCP tool for YouTube upload. Then I thought, what if I could generate not one video, but a full playlist? And step by step, that small experiment turned into one of the biggest AI projects I have built so far. A full YouTube automation system. It can research topics, generate scripts, create voiceovers, build visuals, design thumbnails, assemble videos, and publish them on schedule. In this video, I want to show you what I built, how it works, and why this project connects almost everything I love. Software engineering, AI, music, video editing, and automation.
Hello, my name is Andre.
I have been working in IT for over 30 years, and for the last 15 years, photo and video creation has been my main creative hobby. Over the last 2 months, I have been building one of the biggest AI projects I have done so far, a YouTube automation system. The idea started very small. I wanted to create some music for my gym sessions. I used AI tools like Suno to generate a track, then created an image, added visual equalizer animation, and built a simple video using .NET. When I saw the result, I thought, okay, now I want to upload this to YouTube automatically. So I built an MCP tool that could upload a video file to YouTube. But after that, the idea started growing. If I can upload one video, why not generate a full playlist? If I can generate one playlist, why not generate full albums? And if I can automate music videos, why not automate documentaries, storytelling channels, shorts, thumbnails, scripts, voiceovers, visuals, and publishing? That small experiment became a full content machine. Today I want to show you what I built so far, what works, what is still messy, and what I learned while building it. The first part of the system was music automation. I created a channel structure where each YouTube channel can have its own playlists, albums, prompts, style, and publishing schedule. For example, I can create a new channel, define the idea behind it, and then use my prompt system to generate album concepts. The system knows what albums already exist, what style the channel uses, and what kind of music should be generated next. Inside the prompt system, I have custom prompts for different tasks. One of them is album generation. The system can generate a full playlist structure, the title, the theme, the track ideas, the energy curve, the mood, and the style. For example, an album can start with a slower track, then move into higher energy, then come back down at the end. Everything is generated using prompts, but the important thing is that it is not just one random prompt. It is a structured system. The system understands the channel, the previous albums, the target audience, the style, and the purpose of the playlist. After the album is generated, I can generate images, music, thumbnails, and videos. Then I can select which YouTube account should publish the content, create a playlist, and release everything on schedule. The titles, descriptions, metadata, and publishing flow are also automated. So from one idea, I can generate a full music playlist and prepare it for YouTube. After I finished the music part, I started thinking, if I can automate music videos, why not automate other types of channels? So I started building more channels. One of them is an animal documentary style channel. Another one is a storytelling channel with images. Another one is for short videos and reels, where I can publish daily content. And another one is called Redacted Briefing, where I create documentary-style stories based on historical events, documents, and research. Let me show you how one of these documentary episodes works. The pipeline starts with an idea. First, I brainstorm the channel concept with AI, then I define the branding, tone, episode style, and target audience. After that, I can create an episode. For each episode, the first step is research. The system searches for available sources, articles, documents, and background information about the story. It collects this information and builds a knowledge base for the episode. The second step is the blueprint. The blueprint defines how the episode should be structured. It includes the hook, the chapters, the story flow, the main tension, the key facts, and the overall direction of the episode. The third step is the script. Using the research and the blueprint, the system generates the full narration script. I can choose the model, the style, the narration type, the words per minute, and the density of the writing. For the best results so far, I have been using Claude Sonnet for script generation. The goal is not just to create random AI text, the goal is to create a structured, watchable, documentary-style story. After the script is generated, I review it. I can run it through another AI check, fact-check it, improve the pacing, and decide whether the story is strong enough to publish. When the script is ready, I move to the editor. The editor splits the story into segments. Each segment can be edited separately. I can add new segments, remove parts, rewrite sections, or insert something like a subscribe block. This gives me control over the final story before moving to voice generation. The next step is voice. The original script is plain text, but before generating the audio, the system converts it into narration markup. It adds pauses, rhythm, and better structure for voice generation. Then I can choose a voice. I have different voices configured in the system, including voices created in 11 Labs specifically for different channels. I can generate each segment separately, listen to it, regenerate it if needed, and then merge all voice segments into one final narration file. For example, an episode may be estimated as 12 minutes based on the text, but after voice generation, it may become 11 minutes and 32 seconds. That is why I need the real generated audio, not just text estimation. After the voice is generated, the next step is transcription. This is important because I do not want to listen manually to every full episode just to check if something went wrong. The system takes the generated audio and transcribes it back into text. Then it compares the transcription with the original narration. This helps me check if anything is missing or incorrectly generated. For example, one transcript slice may have a 91% confidence score. It will not always be 100%, because converting speech back to text can introduce small differences. But this gives me a strong signal that the audio contains what I expected. This transcription data is also useful for the future. Because the transcript has timestamps, I know exactly when each phrase is spoken. That means later I can use this timing for subtitles, sound design, visual effects, and automatic scene timing. This is one of the areas I want to improve next. The next part is context. In the context step, the system analyzes the story and creates a visual style for the episode. It can define the color, theme, mood, visual direction, and other style settings. The output is a large structured JSON file that describes how the episode should look and feel. After that, I move to visuals. The visual system depends on the type of content. For some videos, I can use AI-generated images. For other videos, I can use external media sources. I have integration with Pexels, so I can search for free stock videos and import them into the project. I can also download video from other sources, analyze it, split it into segments, and attach small parts to my episode. The system can match video clips to the right parts of the script. For example, if I am working on an animal documentary, I can search for related videos, preview them, import them, and link them to specific segments. Then those clips appear on the timeline and can be used in the final video. For AI-generated images, I tried several approaches. The one that worked best for me so far is what I call Photo V2. The idea is simple. The system analyzes the full story, splits it into visual moments, and generates images for each segment. Instead of creating random images, it creates images based on the narrative structure of the episode. This gives the video a more consistent visual flow. Once the images are generated, I move to composition. This is where the episode becomes a video. I built a custom UI where I can see the whole episode as a timeline. I can preview the video, enable or disable effects like digital noise, vignette, highlights, and text overlays. The composition system takes the narration, images, timing, effects, and visual plan and builds the final MP4. This part is still in progress. Some things work well and some things still need improvement. But the main idea is already there. I can generate a full video from inside my own UI. The next big part is sound design. This is another project I have been working on. Over the last 15 years, I collected a large sound library, almost 10 or 12 gigabytes of sound effects. I built a tool that analyzes this library, removes duplicates, and creates searchable metadata for each sound. After processing, the library became much cleaner. Now I have around 4 gigabytes of useful sound assets. The system can search sounds, show where they are located, and play them directly. The plan is to connect this sound design library to each episode. Because I already have transcription timestamps, the system can eventually suggest or attach sound effects at the right moment in the story. This part is not finished yet, but it is one of the most exciting directions for me. Another part I am currently working on is called visual beats. The idea is to generate infographics and animated visual moments from a script. For example, I can paste part of the narration and the system can generate a visual explanation or infographic for that moment. Each visual beat could then be exported as an MP4 and reused inside the final video. This could be useful for documentaries, explainers, historical videos, technical videos, and many other formats. I am also working on visual titles, subtitle automation, and better tools for short visual clips. The final step is YouTube publishing. When the episode is ready, the system generates YouTube titles, descriptions, chapters, metadata, and thumbnail options. Because the episode was built from research, the description can include relevant context and sources. Because the system knows the chapter structure, it can create proper timestamps. Because each channel has a schedule, the video does not need to be published immediately. It can be queued and published at the right time for that channel. For example, Redacted Briefing may publish 2 videos per week. Another channel may publish daily short videos. The goal is that each channel has its own workflow, schedule, tone, and automation settings. So this is what I have built so far. It started as one simple AI music video, and in 2 months it became a full YouTube content automation system with multiple channels, research, scripts, voice generation, visual planning, composition, sound design, thumbnails, metadata, and scheduled publishing. It is still not perfect. Some parts are messy, some parts are experimental, and many features are still in progress. But that is exactly why I started this channel. I want to document the process, share what I learn, show what works, show what does not work, and build a small community of people interested in AI, automation, software engineering, and creative tools. I will make separate deep dive videos about different parts of this system: MCP upload, prompt architecture, script generation, voice automation, transcription, visual generation, sound design, video rendering, and publishing. All the technology I use, all the experiments, all the mistakes, and all the results, I want to share them here. If you want me to go deeper into any specific part of the system, let me know in the comments. Thanks for watching. Subscribe if you want to follow the journey, and I will see you in the next video.